right, so we are going to get started. Our first assignment this week is going to be the review for test 2. And like I was saying to the people on campus today, is I have some pretty lofty goals for us this week, and that would include us doing this whole review today, which looking through it, it's got 25 problems, and I really don't see that happening. So what's probably going to happen, even though I have this Sunday, is review for test 2, 8-1, 8-2. In all reality, it'll probably be review for test 2, test 2, and 8-1. So we'll see how far we get, but 8-2, there's a good chance it'll be pushed to next week, which is fine. But what this means is, because on test 1, we did the review, it also took us 2 days. So we can't continue to keep doing that every time we have a test review for 2 days. So for test 3 and test 4, what my plan will be is to do a review, but not during class, and just post it in the content folder for that week. So you'll still have the whole review to go along with your packet. We just can't spend 2 days on it. So that's probably what we'll do for test 3 and test 4, just to save us those days and get through what we need to get through. Okay, but review for test 2, number 1. So this one goes back to when we were talking about whether functions were even or odd or neither. So you were even if you were symmetrical with the y-axis, which means so here's my y-axis. If you fold your sheet of paper on the y-axis and one side exactly mirrors the other side, then you are an even function, right? You can think of even functions like quad functions, right? The u functions that look like that, that's an even function because it's symmetrical with the y-axis, okay? An odd function is what we call symmetrical with the origin, okay? And you can think of that as something like the cubic function, okay? So what that means is if you rotated this or flipped it across the x and then flipped it across the y, then it would lie on the other part. So think about this. If you flip this across the x, it would all of a sudden look like this. Right? If you flip this upside down, and then if you flip that across the y, then it's going to lay on this part. That's what makes you odd. Okay? So when we're looking at number 1, what does it look like? It looks like that, which would make it what? Even, right? Because it's symmetrical across the y-axis. All right, number 2 is in our transformation section, okay, with the inside and outside numbers and how they shift the graph. So remember, your inside numbers, numbers that are inside parentheses or inside a square root symbol, are going to shift you horizontally left and right, but you go opposite the sign, right?
Miss Hanson?
Yep.
What was number 1 supposed to be about?
Even, the symmetrical, it was even because it was symmetrical across the y-axis.
So what's the answer to number 1?
Even, B. Are you looking at something different maybe?
No.
Do you see it now?
No.
It should look like this. Is this what you're looking at?
Oh yeah, now I see it.
Okay, yeah, so this even.
Okay, I got it now.
number 2 says, describe how this graph can be obtained from one of the basic graphs. So first of all, what is the basic graph that this function is going to make? This is what tells you that, right? That's what's going to give it the U shape because it's quadratic. If its highest exponent is a 2, that makes it quadratic. So now you're going to start off with the graph of x squared. And then it says you're going to shift it blank 3 units and blank 5 units. So let's see, this is what's going to shift it to 3 units, right? Since it's an inside number, that's going to shift it left and right, but you go opposite the sign. So since it's plus 3, I'm actually going to go to the left 3. Outside numbers shift you up and down, and you go with that sign, right? So this one is going, since it's plus 5, it's going to shift me up 5. Now, then it's going to ask you to graph it. So remember, when you graph it, in this section, it was a little different than other sections of graphing. You're first of all going to come over here to all those shapes. I think there's more. There's like a V and everything. So the first thing you're going to have to do is tell it you want it to be that shape, right? Since it's quadratic, you want it to be a U. And then you go and you actually click anywhere on the graph. What it's going to do is it's going to put the standard there, right in the middle. And then you do those shifting things that are down there. You do a horizontal shift to the left 3. And then you do a vertical shift to the, or up 5. So what it'll do, when you tell it to do that, it'll shift it to the left 3 and up 5 and move it where it's supposed to go. So you're not actually plotting points on that one. You're just telling it where to move that U shape. Right, number 3. F of x equals the square root of x minus 2. Okay, and this one has, it's going to shift it this way, blank units. So it's got 2, and each one of these will have a drop down. So you're not just like trying to pick out what the words are from the air, right? So it's going to shift it where, how many units. So this is an inside number. So it's going to shift it left and right, but you go opposite the sign. So since it's minus 2, I'm actually going to shift it to the right 2 units. And then it's going to be a multiple choice. So the original standard square root graph looks like that, and it starts right in the origin, but you want to pick the one that has been shifted to the right 2 units. That would look like that. Only one of them is going to be shifted to the right, which looks like B on that one. All right, number 4. Another one it looks like, describe how the graph of the function can be obtained from one of the basic graphs. So we're not going to have to graph this one. We're just going to have to tell what all this is doing. So a negative, open parentheses, x minus 2 squared plus 3. So it tells you you're going to start with the graph of x squared. You're going to shift it blank units. Now, it's going to give you a drop down. Here's what's going to be your options. Do you see how the first drop down, they're all left and right options? which means it wants to know which one is your horizontal shift, right? If your options are all left and right, you're looking in here for that. Right? So since the -2, you're going to shift it. Where does -2 on the inside tell me to shift it? To the right 2. Then the second sentence says, then reflect it across the blank axis, and your options will be x-axis or y-axis. Where does this shift it? Remember, it shifts it upside down, which means it's going to reflect it across the what? X-axis. We actually don't have anything that's going to shift across the y-axis in here. And the last drop down, all the options are up or down. So it's talking about the vertical shift, which means it's talking about this number. Since it's on the outside, that's your up or down shift. And since it's +3, we're going to go up 3.
Miss Hanson,
Yeah?
how's it x-axis?
The x-axis is where it's going to reflect across because of this right here, right? That negative symbol makes this shape go upside down like that. So it flips it. If my x-axis is, this is my x-axis, right? It goes like this.
Yeah.
That's what it means when it reflects it across the x-axis. It makes this go upside down.
Oh.
And this is what does that for that graph.
Ah, okay. I got it now. I see what I missed.
All right, number 5 says find the zeros of the following functions. We have f of b equals b squared plus 12b plus 27. What kind of function is this? Quadratic. If you are finding the zeros of a quadratic function, that is going to be pretty much, if you've got that program, 3 points on this test, right? You just go to your quad program. So if you don't have it yet, you need, and you want it for this test, this is the week you need to come get it. Right? So if I turn my calculator on. So if you have the program, it'll be under PRGM. If you got it from me, you have all these programs on your calculator now. Make sure you go to the one that says quad and hit enter twice. And then it's going to ask you for what? Your A, B, and C. Remember what those are. Your A is the number in front of B squared. Your B is the number in front of the B. And your C is your constant. So that's what you're putting in your calculator for the program. So when it asks you for A, what's in front of that B squared? Since I don't see anything, that means it's automatically a 1. Your B, the number in front of B this time is 12. Your C is your constant, which is 27. And hit enter, and there are your 2 answers. So -3 and -9 are your answers. All right, number 6 is the same kind of problem, right? It still says to find the zeros of the function, and it's a quad function. So I've got f of x equals 2x squared minus x plus 9.
Is this number 6?
Yeah. Oh, well, remember, you're supposed to bring up your calculator, right? On Wednesday? Don't forget. So let's see, we're doing another quad function. So again, I'll just go to program and hit quad. And again, it's going to ask me for my A, B, and C. So again, it's just 2. What's in front of your X? -1. Good, -1. And then your constant is 9. Hit your enter, and there are your 2 answers, right? Whenever your answer looks like that, that means we're going to have to use the whole quadratic formula to solve that. Okay? When my answer on the last one just ended up being -3 and -9, this quad function was solvable by factoring. You could have factored it to solve it. But when your answer ends up like this, 1 plus I squared of 71 over 4, and also minus, that means that was going to be a long drawn out problem using the quad formula if you didn't have the program. Do you have entered into the program on your calculator? Yeah, you do. Okay. All right, number 7. So again, that's the 2 answers for number 6. Okay, it showed them separately in my calculator, but you can just combine those and put that plus and minus together. All right, number 7 gives me the function x squared minus 2x minus 8 equals 0. And then it also gives me the picture of what that looks like. With those 2 points highlighted, right? These 2 points right here are highlighted. So what it wants to know first are what are the x-intercepts, and then what are the solutions? Well, the x-intercepts, remember, x-intercepts are points. And points are always labeled with ordered pairs. They're not just the number, right? Order every point. If you're a point, that means you're an ordered pair. So where does this one cross the x-axis? At that -2, which means its ordered pair is -2. And if you're an x-intercept, what is always your y? 0. Right. So -2, 0, and this one crosses at 4, so it'll be 4, 0. And then it asks for what are the solutions? When it's talking about the solutions, it's not wanting the points, it's just wanting the 2 numbers that are the solutions or the answers to this quadratic function, which is totally related to its x-intercepts. The solutions are just -2 and 4. And you do not put parentheses around that, right? Because you do not want to try and tell Math Lab that this is a point as an ordered pair. Okay? So these, it all ties together, right? If I put the A, B, and C of this quadratic function in my quad program, so my A being 1, my B being -2, and my C being -8, look what it's going to give me. So A is 1, B is -2, and C is -8. And when you hit enter, what does it tell you? 4 and -2, right? Which are your solutions, and also where that quad crosses the x-axis. It's all tied together, same thing. Oh, this is this one. A wire is stretched from the ground to the top of an antenna tower. So here's my antenna tower. Here's the wire. Here's the ground. So remember, that shape would make a right triangle. And the information that you were expected to know before this problem was the Pythagorean Theorem, right? That tells you that this side squared plus this side squared is going to be equal to this side squared. So let's see the information that it gives us. The wire is 10 feet long. Well, here's my wire. So it's telling me that that side is 10. The height of the tower is 2 feet greater than the distance from the tower's base to the end of the wire. So let's think about that. The height of the tower, here's my tower, is 2 feet greater than the distance from the tower's base to the end of the wire. So this side is 2 feet longer than this side. So the way I'm going to write that is I'll call this side X, which means, yes, this one is X plus 2. That's right. So if I can solve this for X, then I will know what this side is. And once I know what this side is, I can add 2 to it to get this side. So let's set this equation up according to this formula. So I need this side and square it. So X plus 2 squared plus this side squared. So plus the X and square it is going to be equal to this slanted side squared. So 10 squared. So let's see, what does X plus 2 squared mean? It means I need to FOIL that, right? X plus 2 times itself. So let's see, if I FOIL that, X times X is X squared. My outer, X times 2 is 2X. My inner is another 2X. And my last 2 times 2 is positive 4. Now, look at these 2 terms in the middle there. I can put those together, right? I really have 4 X's. Since I have 2X and 2X, I actually have 4 X's. So I've got X squared. Put those together to get plus 4X. Plus 4. Bring down this plus X squared. And that's going to be equal to 10 squared, which is 100. So look what you've created. This is why this was in this quad section, is because this is a quad function, right? If its highest exponent is a 2, that means I'm jumping to my quad program to solve it. But in order for that to happen, all the terms need to be on one side together, set equal to 0, so your A, B, and C will all have the right sign and number and everything. So that's what I need to do. I just need to rearrange this equation so that I can put it in my quad program. So let's see, I need to, on the left side, I can put my X squareds together since they're like terms. So I've got 1 here and 1 here, so I actually have 2 X squareds. Bring down my plus 4X plus 4 equals 100. All right, I'm just going to rewrite this up here. So I'm at the point where I have 2X squared plus 4X plus 4 equals. So now all I have left to do is to move the 100 over there to set it equal to 0. So I'll subtract 100. So the right side will be my 0 like I want it to be. I put the minus 100 underneath the 4, because that's the term that it's going with, right? It's like term. So let's see, I've got 2x squared. Oh. Plus 4x. Then I have 4 minus 100, which will give me negative 96. So now I'm ready, A, B, and C, to go in my quad program. So let's see, program quad. My A will be 2. My B is 4, and my C is negative 96. Hit enter. So the solutions to this program, or to this equation, are 6 and negative 8. So I got 2 solutions, but this x can only be one thing, right? So what is this x representing? It's representing the distance from this side to that wire, which means that's not going to be a negative number, right? It's a distance. It's going to be a positive number. So that's why your x is 6, which means the height of the tower will be 6 plus 2, which makes it 8. So the distance from the wire, or the distance from the wire to the base of the tower would be 6. And then the height of the tower would be 8.
Question.
Yeah.
Do you know why my calculator's doing this? I've never done this before. Doing that, but it won't let me clear anything out.
Yeah.
Minutes ago, and then it.
Oh, it's like it's spinning.
Yeah. So it's
Oh, I just hit enter again and it stopped.
Oh, really?
I don't know.
That's strange.
That usually that just means it's still thinking about something, but I don't know what it would still be thinking about right there.
The calculator's like, excuse me, I'm not doing that.
Yeah.
I'm over it.
So let me tell you this. So if your calculator does ever do something like that, don't ever take all the batteries out. And when your calculator is dying and you do have to replace batteries, replace them one at a time. Because if you take all the batteries out, all your programs are going to disappear. Your calculator will totally reset itself.
Oh, wow.
So replace your batteries one at a time if you decide, if you're All right, the next one is another Pythagorean theorem problem. This one's talking about the ladder. So the foot of an extension ladder is 7 feet from a wall. Here's my wall. There's my ladder. So again, you'll notice that that makes a right triangle, which means, once again, you can use the Pythagorean theorem to solve for your x. So let's see where our numbers go. The foot of an extension ladder is 7 feet from a wall. So here's the foot of the extension ladder. And there's the wall. So here's that right there is 7 feet. The height that the ladder reaches on the wall, which is this height right here, and the length of the ladder, here's the length of the ladder. So here's the height that it reaches on the wall. There's the length of the ladder. It just says they are consecutive integers. So what that means is one of them comes right after the other. Okay, so which one's the short? The height that the ladder reaches on the wall and the length of the ladder. So this side is your x, which means if this is the next number after this, the consecutive integer, it's just going to be x and add 1 to it. And I think I'm recalling that the day that we went over this, it was like 9:52 when I was trying to squeeze this in. So let's see. We need one of these sides squared. So this side squared would be x squared plus the other side squared. So 7 squared equals the hypotenuse, which is the slanted side, squared. So x plus 1 squared. So let's see what we got. So it's looking like it's going to be another one of those quad program problems because it's x squared. Okay, but let's see what happens. So that'll just stay x squared. That'll turn into plus 49 equals. I'm going to do the x plus 1 squared over here because that means I'm just going to have to FOIL again. So x times x gives me x squared. My outer x times 1 is 1x. My inner is another 1x. And then my last 1 times 1 is 1. Put your x's in the middle together, so you really have 2x in the middle. So when I did this x plus 1 squared, it gave me x squared plus 2x plus 1. So remember, if you're going to use the quad program, you've got to get your equation set up for it, which means get everything on one side, set it equal to 0, which means I need to put this x squared over here with this one. But what happens when you're trying to do that? If you subtract x squared there, you got to do the same thing here. What happened? Both canceled out, right? So all I'm left with is 49 equals 2x plus 1. So now this is not a quad problem anymore, right? My squareds went away. So now, remember, all I need to do is figure out what x is. So now I'm just, there's my x. I just need to isolate it, get it by itself. So I need to subtract 1. So 48 equals 2x and divide by 2. So your x equals 24. So where is x represented? Here's my x. So it's 24, which means this side, which is my ladder, would be what? 25. So what's the question asking me? The only thing it wants to know is the length of the ladder, which means this side, right? That's your ladder, which means the length of the ladder is 25. Right? Number 10. Number 10 gives me a parabola, and it actually names its vertex. Right? The vertex of the parabola is the point at which it changes directions. So it gives me that point. So it gives me this parabola, and then it says this point right here, which is its vertex, is at -1, 4. Then the actual first question is, what's the vertex? So don't try to make that any harder than it is. It told you what the vertex was in the picture. -1, 4. Then it wants to know, what is the axis of symmetry? Now remember, the axis of symmetry is always written as an equation because it is an equation. It's the equation of the line that makes that parabola symmetrical. The equation is always going to be starting off with just x equals And then remember, you can get all this information from the vertex. What is your x here? -1. So that's the equation of the line. Then it wants to know what's its minimum or maximum value. Anytime it's asking about a value, it's asking it what is the y. Value is always the y. So this one would actually be the minimum because it's the bottom of it, right? And its value would be 4. Not y equals 4. I should probably not write that. Not y equals 4. When it's asking about a value, it just wants that number. All right, number 11. X squared plus 10x plus 9. So first of all, it wants to know what the vertex is. Now remember, we can actually do this in our calculator. The only thing we need to know before we can go to the calculator is whether this vertex, is its point going to be its minimum or its maximum. So in other words, is this parabola going to have this shape or this shape? Where am I looking for that? Right here, right? If there's a negative, that would flip it upside down. So this one's vertex is going to be at the bottom of it, which means it's going to have a minimum. So now go to your y equals. Clear it out with whatever's in there. Type in this function, so put in 2x squared plus 10x plus 9. So let's graph it first, so just to make sure that it's a parabola like I want it to be. Does everybody see that parabola, that U shape? So what you want to do is find this minimum, because that's going to be its vertex right there, right? So hit your second button and then hit this trace button, because what you want to do is get up here to this calc function. That's why you hit your second button. So second and then trace, which is right next to graph. So which one of these things am I trying to find? I'm trying to find its minimum. So go down to number 3 and hit enter. Now, remember, what it's going to do is say, okay, here's where your cursor is. Make sure you have it on the left side. So let's see. My cursor is at, first of all, these numbers right here tell you where your cursor is. It's at 0, 9. And you can kind of see it blinking up there. Yeah. So is it on the left or right? It's on the right side. But you want it on the left. So hit this left arrow key. So see it coming down? Well, it's just going to keep coming down, and then it's going to pass through the vertex. And then anytime, once it gets past it, it doesn't matter how far past it is, just hit enter. So just get it past the vertex and then hit enter. And then it's going to say, okay, now put it on the right side. So now I'm going to hit the right arrow and just take it back through the vertex and then hit enter, and then it's going to say guess and just hit enter again. So that point right there is your vertex. Negative 2.5, essentially. Negative 3.5. Now, when you type that into MATLAB, what is it not going to like about how that vertex looks? That it's that it's decimals.
Oh, decimals. I'm sorry. Right.
It has to be a fraction. Now, I would definitely keep this handy because you're going to have to plot that vertex when you graph it. Mm-hmm. You don't really want to see it in a fraction when you're trying to move a point around. Okay, you're going to want to see it in decimal, but for when you type the answer in to MATLAB for the Vertex question, it's going to want those as fractions, which means what are you going to do? Just type in negative 2.5 on your home screen. And then hit what? Math, enter. So negative 5/2. And then do the same thing with the negative 3.5. So just type in negative 3.5. Math, enter that to see that will be negative 7/2. So that's what you're going to type in for the Vertex. And then use this for the rest of the questions, because then it's going to ask you, okay, where is its axis of symmetry? And remember, it's going to say, type in the equation of the line. What's the equation going to be? X equals whatever the x of your vertex was. Then this one's going to ask you, does it have a minimum or a maximum? This one has a minimum. And what is its minimum value? Negative 7/2. And then it's going to ask you to graph it. So remember, when you're graphing it, the first thing it's going to ask you to do is plot the vertex on this one. That's when this is going to come in handy, because when you're moving your cursor around in MATLAB on the graph, it's not going to move it around in fractions. It's going to move it around in decimals. Okay, so this will definitely be handy for that. True or false, the graph of h of x equals x plus 5 squared. Can be obtained from moving the graph of x squared left 5 units. So it wants to know, is this true or false? Where does this inside number move you? It does move you left and right. And you do go opposite the sign, so that plus 5 will move you left 5. All right, number 13. It's another one of those where you got to find the vertex and then use the vertex to answer a bunch of other questions. So this graph is f of x equals x squared minus 10x plus 24. The first thing it wants to know is the vertex. So let's go to your y equals and clear it out. Put in this new function, so x squared minus 10x plus 24, and graph it. So there's my parabola. Let's find its vertex. Is it a maximum or a minimum? It's a minimum, right? The vertex is down at the bottom of the parabola. So I'm going to go to second. And then you hit your trace button, which is right next to graph, to do the calc. And you again want to calculate that minimum. So go down to minimum and hit enter. Are you with me? So it wants to know, are you on the left side? I can't see my cursor. I have no idea where it is. Now remember, this tells you this x equals 0, y equals 24. That tells you where your cursor is. Where would 0, 24 be? It would be right here, right? It would just be farther up the y-axis, which means it is on the left. If you weren't sure though, you can hit the right. See when I'm moving the cursor to the right? You can see it coming down the y-axis. So now it's at 14, which means I'm about to see it. My highest y that is showing on this actual picture is a 10. So once it gets down to 10, you should start being able to see it. See, there it is. So it is on the left. So go ahead and hit enter since it is on the left. Then keep moving it to the right to get it over to the right side of the vertex. And hit enter twice. So here's my vertex is at 5, -1. Okay. And that's 5. Okay. And that's negative. Okay. Yeah. Where the vertex is, and if anything, the vertex might be a 0.5 decimal, but if you get something way like 2.6942, then something's wrong. It's not going to be a number like that. Okay. All right. So that's the vertex. Determine whether the parabola has a minimum or maximum value. So it's a positive x squared, which means it's a right side up parabola, which means it's going to have a minimum value. And what is the minimum value? -1. Oh, and this is the one where it wants to know the range. So let's look at what this looks like. So 5, -1. So it's over to the right, 5, down 1. Here's where this parabola is. It wants to know the range. So let's see, when you're talking about the range, you are talking about the y values of this function. Well, you can kind of say, okay, the minimum, this is the lowest y value of this whole graph. That's why it's called the minimum. Where does the y's go from here? Go up to infinity. So what's the lowest y value? -1, and it does touch -1. So I do put a bracket around the -1 because -1 is a y value that's in this picture. And then, like we said, it goes up to infinity, and then infinities always have parentheses. All right, and then the increasing and decreasing. So let's label. This side's coming down until it gets to this point, and then it goes up. So this is my decreased side. And once it gets to the minimum, then it starts increasing. Now, when we're talking about increasing and decreasing, first of all, everybody's in parentheses, and you're using the x coordinate. So everybody's in parentheses, and you're using the x of the turning point. So what does it want to know first? First thing it wants to know is the increase.
5 to 30.
So it starts increasing here, right? This is where it stopped coming down and started going up. So it started at 5, and then it went up to infinity. So there's my increase. The decrease.
Negative infinity.
Right. If you start on this side, you're at negative infinity until you get to what? 5. There's your decrease sign.
Make your infinities look so good. I don't know.
Really?
Yes.
Because I've drawn about 10 million of them in my lifetime. And the faster you draw them, the better they're going to look. Okay, so it is 9:50. So we're going to stop here, just like I don't know why I thought I could do this all in one day. There's no way. So we'll start with number 14 on Wednesday to finish this. So today in support, we're going to do the support for 8.1. Okay, but I will finish this on Wednesday. Oh wait, I got Morrison, Peak, Clark, Morrison, Peak, Clark, Hines, Keys, Barron, Hauser.
Oh, Miss Hanson, get me.
Got you.
Got me.
I got you. Yeah,
Okay.
so I think I got everybody. I've got Acker, Barron, Bro, Chor, Clark, Ellis, Hines, Hauser, Keys, Morrison, Payless, Peak. Okay. All right. See y'all Wednesday.
Okay.